Edexcel A-Level Mathematics, October 2020, question 3. At time t seconds, where t is larger than or equal to 0, a particle p moves so that its acceleration, a meters per second squared, is given by a equals 1 minus 4t I plus 3 minus t squared j. At the instant when t equals 0, the velocity of p is 36i meters per second. So for part A, we need to find the velocity of p when t equals 4. So we've got the acceleration. We know that acceleration is the derivative of velocity. So to get back to the velocity, we're going to integrate it. We're going to integrate the I and the j parts separately. So the integral of 1 minus 4t is t minus 2t squared. The integral of 3 minus t squared is 3t minus a third t cubed. And we've also got our constant of integration, our c, on the end. It's very important to put that on there. We're told at the beginning that when t equals 0, the velocity is 36i. So if we substitute those into what we've got already, we get that 36i equals 0i from the t minus 2t squared plus 0j plus our c, which means c must equal 36i. Putting this back into our original v with all the other parts of the I, we get that v equals t minus 2t squared plus 36i plus 3t minus a third t cubed j. So all that's left now is to put our t equals 4 in. So v is going to equal 4 minus 2 times 4 squared plus 36i plus 3 times 4 minus a third times 4 cubed j, giving us a final answer of 8i minus 28 over 3j. For part B, we need to find the value of t at the instant when p is moving in a direction perpendicular to I. So if it's perpendicular to I, it's moving vertically, hence the I section of our velocity is equal to 0. So t minus 2t squared plus 36 equals 0. We now need to solve this quadratic, either using the quadratic function on the calculator, using the quadratic formula, whichever you like. It would give an answer of t equals 4.5 or minus 4, but we're told that t is larger than 0, so we can scrap the minus 4, giving us an answer of t equals 4.5. At time t seconds, where t is larger than or equal to 0, a particle q moves so that its position vector, r meters, relative to a fixed origin O, is given by r equals t squared minus t I plus 3tj. We need to find the value of t at the instant when the speed of q is 5 meters per second. So to start with, we're going to find the velocity. Velocity is dr by dt. So differentiating both the I and the j parts of our r, we get that v equals 2t minus 1 I plus 3j. Now in the question, we're dealing with speed. So to get to a speed, we know that our speed squared is equal to the sum of the squares of the I and the j components. So modulus of v all squared equals 2t minus 1 all squared plus 3 squared. We're told that the speed of q is 5. So 5 squared equals 2t minus 1 all squared plus 3 squared. Well, 5 squared is 25. 3 squared is 9. So taking 9 from both sides, we get that 16 equals 2t minus 1 squared. 2t minus 1 going to equal the square root of 16, so 4. Note that I've ignored the negative square root here because we're dealing with t larger than or equal to 0, and that would have given us a negative t. Adding 1 to both sides, 2t equals 5, hence t equals 2.5. If you've enjoyed this video, remember to subscribe to the Doing Maths channel to keep up to date with all the latest releases.